Welcome to By Excellence Tutorials, and we're going to solve a question here under photoelectric effect. Yeah. What would the minimum work function for a metal have to be for visible light? Okay, so we've been given a range to eject photoelectrons. Okay, now have you subscribed yet to the YouTube channel? If you have not yet subscribed, kindly click on the subscription bell and also on the notification bell so that you get notified each time I upload a new video. And if you happen to look for a private tutor, you can get in touch with me using the numbers of the email that I've dropped in the description box. Okay, so how do we solve that one? Okay, so we know, similarly, like in the previous video, what we're going to do. So if you have not watched the first video on photoelectric, you can check it out. So we know that work function is given by that. Now, what would be the minimum? We're looking for the minimum. So for us to get the minimum, basically we have just to get, since we've been given the range, we have to pick the lowest or the smallest wavelength and use that smallest wavelength. Then we'll get the minimum work function. If we pick the maximum wavelength, we'll get the maximum work function. So the minimum here wavelength is actually 380 nanometer, okay, which is 380 by 10 to the power negative 9 meters. So the minimum work function is actually 6.626 by 10 to the power negative 34 joules second. Okay, so I'm using the electron volt. So I'm converting to electron volt, where I'm dividing by 1.602 joules per electron volt. And then here we have the frequency here, but here we have the wavelength. But we don't need to worry because we know that frequency is given by speed over wavelength. So the wavelength is going to be down here, and we're going to have also the speed of light here. If we substitute here, it's going to be something like this. Okay, 8 meters per second. And then we also place our wavelength meters like that. So the minimum work function here is going to be 3.26 electron volts. So this is how you solve that one. So thank you so much for your time.